Welcome to the presentation, Classroom Strategies, Elementary Common Core Math. Let's begin with a clear goal of the Common Core Math standards. The standards are intended to be rigorous, research-based for every student to be successful, whether heading to college or the workforce. In Arcadia, we also have an expectation for students to be competitive in a global society as well. As parents, we want our kids to be successful and have the best opportunities. And as teachers and AUSD, we want our students to be successful at the best college or university of their choice, or to be prepared for the best career opportunity available to them. You may have already heard about the new shifts within the Common Core. In particular, math has 3 shifts. We have had to shift the way we think about teaching math to better support student success. The first shift is focus. Spend more time on fewer things. Instead of having to cover a long list of standards, teachers can spend more time going deeper with fewer standards, helping solidify student understanding of key concepts. Primary teachers especially appreciate how developmental Common Core math is. Instead of rushing through concepts that are too abstract for our young learners, Common Core math helps students build concrete understanding. The second focus is coherence, builds between grade levels. Common Core math helps students learn math through strategies that are built upon at each grade level. Students in TK and kindergarten are learning math skills that they will continue to use all the way up to 5th grade. In this presentation, you will see an example of what this looks like. The third shift is rigor, reasoning and sense-making, rather than merely knowing how to solve an equation. This means that teachers are challenging students to solve problems using various strategies that involve reasoning and making sense, often involving multi-step solutions. Many students like to be able to solve problems quickly using a given equation and get the right answer. But Common Core math requires students to endure a productive struggle with more complex math problems, developing their perseverance and reasoning skills. The next part of this presentation is divided into 2 sections, TK through 2nd grade and 3rd through 5th. One of the math tools that K2 teachers have been introduced to is the Rec and Rec. The Rec and Rec is a tool that allows students to make mental images of numbers. Using 5 and 10 as benchmarks, this tool provides learners with the visual models they need to discover number relationships and develop a variety of strategies, including addition and subtraction, doubles plus or minus 1, making tens, thereby leading to automaticity of basic facts. Concepts discovered through use of the Rec and Rec lay a foundation for math understanding in upper grades. Here are some ways teachers are using Rec and Recs and other tools and manipulatives to help students understand number sense. The Rec and Rec is set up like an abacus. It has 2 rows, a top and bottom row, with 5 white and 5 red beads on each row. The beads must all be to the right in its ready position to begin. An important skill TK and kindergarten students need to know how to do is count with one-to-one correspondence. Using the Rec and Rec, students can count the number of beads on each row. They will learn how to count 1 bead at a time, giving it a corresponding number. Students also learn how to show numbers on a Rec and Rec. For example, students can show the number 3 by putting 3 red beads on the top row, counting 1 at a time. As they begin practicing counting numbers greater, they soon realize that every time they count to the number 5, all of the red beads are pushed over. Understanding that they can begin with 5 to count on to a greater number is a skill and strategy that will become helpful in addition with counting on from a given add-in, as well as subtraction with counting backwards. Students will also learn how to utilize the top and bottom rows. In doing so, they're learning how to compose numbers. The number 7 can be composed in different ways. 7 beads on top, 0 on the bottom. 6 beads on top, 1 bead on the bottom. Or 5 beads on top, 2 beads on the bottom, and so on. With this activity, students are actually building fluency with their math facts. These combinations of numbers are called number bonds. Kindergarten and 1st graders are using number bonds to build math fact fluency within 10. We know that students need to know their basic math facts. For many of us, we learned our basic facts by memorizing them, or perhaps with flashcards or timed tests. Some students have a difficult time memorizing them, so teachers are using strategies to make this more concrete for their learning. Making a 10 is a strategy taught to first and second graders for facts greater than 10. By using 10 as an anchor, adding and subtracting is done more efficiently than adding one by one. In this example, the math fact is 7 plus 4. To use this strategy, students decompose or break apart one of the add-ins to make a 10 from the other. If you look at the example pictured below, the 4 is decomposed or split into 3 and 1. The 3 is combined with the 7 to make 10. Then add 1 to equal 11. Students are encouraged to ask themselves, what do I need to make 10? On a Reckon Rec, students can show 7 beads on the top row and see that 3 more beads are needed to make 10. Using the 3 to make a 10, students use number bonds to complete the equation. It's much easier to add 10 plus 1 equals 11 than relying on memorization. Students in upper grades can also use this strategy to add 2-digit numbers by making 20, 30, 50, etc. By using number bonds and making a 10, students will work with numbers and learn to think of 10 as a unit, which is an important building block for understanding place value. As mentioned earlier, coherence between grade levels is an important shift in Common Core math. Number bonds are used in upper grades to help students derive more difficult facts from easier facts. Here is an example of an area model. Students in 3rd grade use areas as a visual to understand multiplication. This model shows an array of 7 by 16. 16 is decomposed into 10 and 6. 7 times 10 equals 70, and 7 times 6 equals 42. 70 plus 42 equals 112. Using 10 as an anchor makes it easier for students to visualize why 112 is the product. In the second example below, the area model shows 25 times 26. Both multipliers are decomposed using units of base 10. Students then multiply each of the sections of the model and add the products to reach their final answer. The area model connects to algebra and algebraic thinking by using the commutative and distributive properties, which are fundamental to number sense and to success in manipulating algebraic symbols and equations. Here are some other classroom strategies. Teachers are using math games, online or hands-on, fewer practice problems, going deeper with less. Students are asked to explain their thinking and demonstrate understanding in various ways. They're given real life and world problems. Students are also assigned to learn Zillion or Khan Academy videos to reinforce or assist with concepts. And students use journals to talk math to help express their understanding. Here are some examples of how a 4th grade student uses their math journal to explain their thinking in steps to solving problems. You notice there are a variety of strategies using visual models as well as explaining their thinking. Thank you so much for watching this presentation. There's more additional information available on our AUSD website under Common Core, or you may use the tiny URL at the bottom to access handouts from this session.